QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. What if this is our quadratic equation? Is this trinomial factorable? Yes or no? The correct answer is no. Next question. What should be the constant that must be added on both sides for completing the square process? The answer is 8. Next, what are the roots of this given quadratic equation? And the roots are square root of 6 over 2 minus 2 and negative square root of 6 over 2 minus 2. Did you get 3 over 3? If not, please continue viewing this video. Let us apply the ideas on factoring this given quadratic trinomial, and if it's not factorable, let us proceed with the second method, completing the square method. But first, let us try to check if this is factorable or not using the coefficients. Your A coefficient is equal to 2. Your B coefficient is 8. And your C coefficient is 5. These are the correct coefficients of this given quadratic trinomial. So we can satisfy, if we can satisfy the AC way, then this means that this given trinomial is factorable, and in solving for the roots of this given equation, we are going to use factoring, which is easier than the next. But if it's not, then we proceed with completing the square method. So let's start with AC. AC is 2 times 5. So AC is the product of A and C coefficients. That's 10. Let's look at the factors of 10. Okay, so 10 can be solved using 1 times 10 times 2 times 5 as well, including the negatives. Negative 1 times negative 10, as well as negative 2 and negative 5. Using these 4 pairs of factors, which will result to 10 when multiplied by their partner, let us try to see if we could add all of this, and if there is a pair that will allow us to return to our B coefficient. If there is a pair, then we can use here again factoring. But when you look at all of this, 1 plus 10 is 11, 2 plus 5 is 7. Here we have negative 11 and negative 7. In short, none of these 4 pairs will result to 8. This is a proof already that this given quadratic trinomial is non-factorable. And if it's non-factorable, we proceed with this method. By the way, I forgot to mention, we also have a method that could solve all types of quadratic equation. It could be incomplete, just like the previous examples where there is no B coefficient and we use the extracting square roots method. We also have without C coefficient, where we use the common number factoring. If this is factorable, then we use by factoring, and since we cannot use this is not factorable, so we use completing the square method. All of those situations can be solved using quadratic formula, but we have yet to present it, so we're going to use this specific method. Completing the square method means we are going to locate or use a specific constant, because this constant here, the 5, will not satisfy a perfect square trinomial. That's our goal. We are going to come up with a perfect square trinomial. So we could proceed with the what do you call this one? We could proceed with finding the roots of this given. So again, this is not factorable. So here's the thing. In the previous videos involving completing the square method, we automatically transpose it here or move it in the other side, where we could have 2x squared plus 8x, and it will result to a negative 5. This happens because the 5 here will not make the entire expression perfect square trinomial. It's only the constant that we are going to change, okay? But look at this given. The a coefficient is also not 1 given here. So we cannot use, or we can still use that one, but there is a problem as to the complexity of the processes. So the suggestion here is we're going to divide all terms, which also includes the constant here, by the coefficient a, so that when we divide that, what we have here is only x squared. And when you divide the second term, of course, that's 4x. And when you have it here, you'll have negative 5 halves. In this manner, we can now locate for a certain c that we will add here, since the coefficient is just 1, so that we could create a perfect square trinomial. And we could compute c. I'm going to denote it c sub 1, so as not to confuse with the original c. And it's computed with this. You have b divided by 2 and square root of a. Now, don't be confused with the square root of a. Of course, this is the new a here, which is 1, not the original a. So I'm going to use a sub 1 here and b sub 1. Well, of course, the formula for this can still be useful for the original a and b coefficients. But it will again be complex enough, especially that your a coefficient is not equal to 1, because you will have a square root of 2, so you'll be having a radical expression here, which again might complicate the rest. So this is my suggestion, and take the square of it. In short, you will have here your b coefficient of 4 over 2 and square root of a, which is 1, and then you square the entirety. So you will have the correct, or the value of 2 squared, which is equal to 4. This is now the c that you need for this new equation here in order for the left hand side to become a perfect square trinomial, and as we can proceed with computing the square. So again, it will become x squared plus 4x, sorry, that's 4x, and then you will be adding 4 here, so that this would be an entire perfect square trinomial. But don't forget to do the same thing on the other side as well, plus 4. And if you're going to add this 2, take note that 4 is 8 halves, or you're going to use LCD. Now that we have here a perfect square trinomial, we can now factor it. I'm using the term factor because that's a factoring process now, even if we are in completing the square method. Take the square root of the first term, x. Take the square root of the last term, 2. Use the sign of the middle term, plus. This is now the square of a binomial expression, which is equivalent to our perfect square trinomial after completing the square method. And the other side, as mentioned, this is negative 5 halves plus 8 halves, so you will have 3 halves here. Now let's take the square root of both sides. When you take the square root of a number, use positive negative. So you have x plus 2 is equal to this positive negative square root of 3 all over square root of 2. I am automatically placing it here because we will rationalize this expression here. So you might want to review as well your radical expression. That is why I'm a firm believer that the topic on radical equations should start first before quadratic equations or quadratics. So when you rationalize this, you'll have x plus 2 is equal to, okay, it will become positive negative square root of 3 times 2 is 6, and your denominator now is a rational 2. That's why it's called rationalizing denominators. Square root of 2 times square root of 2 is actually square root of 4, which is 2. So when you move 2 on the other side, you will have these roots, positive, negative, square root of 6 all over 2. So pardon, over 2, and then you will subtract both sides by a certain 2. These are now your roots. So for your x sub 1, I'm going to separate it here. You will have the positive square root of 6 over 2 minus 2, and for your x sub 2 is equal to negative, that's negative, negative square root of 6 over 2 minus 2. So again, it's a little bit longer because even originally the completing the square method is even longer than the factoring method. What makes it even longer here is that we took this coefficient here and change it to 1, because it will, I will tell you, it will be even a little bit longer if you're going to push for this trinomial to become a perfect square. I mean, yeah, this with this coefficient to become perfect square trinomial. So this is the answer for, or this is the discussion for the answers in this video. This is for QuadQuiz. Subscribe now.